Hi folks, we're going to take a look at page 439, number 18. Okay, so this is an analytic geometry problem. So as we often do, we're going to start with a diagram, although I'm not going to make any effort to be exact because I'm just going to use my diagram as a guide. All right, so let's see what it says. On a site plan for a new house, a water main runs along the edge of the property. So let's say this represents the edge of the property and it goes from point W, okay, which is 1034 to point M, okay, which is 2, 2. All right. It says the water service will enter the house at point 2422. Okay, so let's say the house is somewhere here, H, which is 2422. All right. And then it says the grid intervals on the plan represent 0.5 meters. Okay, so I guess what this is telling me is that if at any point I'm finding a distance, I'm going to have to divide it by 2, since each unit on the grid doesn't represent 1 meter, but half a meter. Okay, so we'll keep that in mind if we have to find a distance at some point. So it says at what point on the water main, okay, so remember the water main runs along the edge of the house, should the connector to take the water to the house be located? So somewhere along here, we're going to need a connector to bring it to the house. Now, of course, the idea is we want this to be the shortest distance possible. Okay, so it makes sense that we're looking for the point. Okay, whatever this is, let's call it P. Okay, this was, I believe, is W and M. Call this P. We want it to be at a 90-degree angle because that we know is what's going to give us the shortest distance, and presumably that's how we want to build this pipe. All right, so step number 1 is to find this point here, and I suspect in B, what length will this connection require? Then we're going to find the distance here. Okay, so essentially it's finding the distance from a point to a line. Okay, it's the same problem, except they've just given us a context here. So in order to find this point, what we're going to do is find the point of intersection between the line created by the water pipe, W to M, and this perpendicular line which passes through H. Okay, so our goal is to find the equations of both these lines so I can then solve the system of equation and find the point of intersection. So the line that's easier to find is the one where I know 2 points. So I'm going to start by finding the line of the pipe, okay, or the water main, I suppose. So here, first I'm going to do is I'm going to find the slope. So the slope of MW is equal to, so difference in y, so 34 minus 2 over the difference in x's, 10 minus 2. So here we have, this is 32 over 8, so that's equal to 4. All right, so now let's find the equation. I'm just going to stick one of these points and the slope into y equals mx plus b. Okay, I don't think you'll be too surprised that I'm going to choose 2, 2. So when y is equal to 2 and the slope is equal to 4, x is also equal to 2, I can now solve for b. So b is equal to, this is 8, so 2 minus 8 is negative 6. So the equation for the line that represents the water main is y equals 4x minus 6. So now I want to find the equation of this line. So again, what do we need to find the equation line? Either 2 points or a point and a slope. Now, because this line has to be perpendicular, I know that the slope is going to have to be the negative reciprocal of 4, which is negative 1 over 4. Okay, and I know it has to pass through the point H, which is 24, 22. All right, so let's find the equation. Stick this into, again, y equals mx plus b. So here, when y is equal to 22, m is equal to negative a quarter, and x is equal to 24. So here we have 22 equals, so 24 times a quarter is 6, so negative 6 plus b. So b is equal to 22 plus 6, which is 28. So our second equation is y equals negative 1/4 x plus 28. All right, so I want to find the point of intersection between these two lines. Okay, that's going to be my point P. Now here, since the y's are already isolated, I'll use substitution. Okay, I'm not going to use elimination because the last thing I want to do, oh, sorry, I just realized that's not the right one. This is the right equation. I don't want to have to work with fractions here to multiply the equations to use elimination. All right, so part A here is finding this point of intersection. So I'm going to replace this y by negative a quarter x plus 28. So negative a quarter x plus 28 is equal to 4x minus 6. To solve this equation, I'm going to multiply both sides by the lowest common denominator is 4, because I don't want to work with fractions at all. So if I multiply this side by 4 and that side by 4, we have 4 times a quarter is 1, so negative 1x. And then 4 times 28 is going to be 80 plus 32 should be 112, but you know what, because I don't want to take a chance, 4 times 28, yeah, 112, not a bad idea to check, equals, so 4 times 4 is 16x minus 24. All right, so I'll bring the x's to this side here to keep everything positive. So 16x plus x is 17x. And here, this is going to be 112 plus 24. I already have the 112 on the calculator, so plus 24 is 136. And x is equal to 136 divided by 17, which I'm going to hope is an integer. And it is, so I lucked out there. So x is equal to 8. And so now, in order to find the y value, I just plug it into one of these equations. So I'm going to plug 8 into equation 1. Okay, so equation 1 is y equals 4 times x, which I know is 8, minus 6. And this is equal to 32 minus 6, which is 26. Okay, so this point of intersection that we were looking for in A is equal to x equals 8, y equals 26. All right, so let's now go to B, which wants us to find the distance of pipe needed, or the length of pipe needed. And this is where I want you to remember that they told us something about what the grid intervals on the plan represent, and they actually represent 0.5 meters each, not 1 meter each. So when I'm looking for this length, okay, I'm actually going to be taking the distance between H and P, but dividing it by 2. All right. So here, how do we find the distance? Well, remember, it's x2 minus x1 squared. Okay. So remember here, we're looking for the distance between H and P. So we've got 24 minus 8 squared. Okay, and then you add the difference in the y squared. So here, 22 minus 26 squared. All right, so here we've got square root of, so 24 minus 8 is 16 squared, plus this is 22 minus 26, negative 4 squared. Okay. Oh, and of course, I forgot, we're dividing by 2. Forgot to write that in. So let's put that into our calculator here, and we've got the square root of 16 squared. Now remember, if your calculator doesn't open brackets up, you need to do that yourself. So again, you need to know your calculator well. Plus, well, negative 4 squared is the same as just 4 squared. And so that's 16.49 divided by 2. So it's about 8.25 meters. All right, now since this question is a context, I'm expecting an approximated answer. All right, so let's do a recap here, because this was, the longest type of analytic geometry problem we have, which is the distance from a point to a line. All right, so step number 1, they helped us out here by telling us to first find this point where the shortest distance is going to occur. And of course, the shortest distance occurs when you're at 90 degrees. So step number 1 was to find the equations of these two lines. Equation 1, because I knew 2 points, and equation 2, I could use the negative reciprocal to find the perpendicular slope plus the point H. Once I had the 2 equations, I solved the system of equations to determine the point of intersection. And once I had the point of intersection, I was able to use my distance formula to find the distance between these 2 points. This had the extra little complexity that each tick on the graph only represented half a meter. So that's why I had to divide that by 2. All right, that's it for this one.